Yeah, now I'm recording. Okay, perfect. Yeah, so ways to express functions, and then I'm going to talk about domain and range of functions. So this is like the plan for today.
Can you click continue, Professor? We see the notice. This meeting is being recorded.
Oh, okay. Perfect. Domain and range of functions. All right, so let's start with the definition of a function. So what's a function? Okay, so first question. So we're gonna try to answer today is, well, very simple.
I don't see your board, Professor.
No?
No, because this thing is blocking it, the message.
You have
really?
to click on it. You have to.
I think you have to click on it.
Okay, got it.
Oh, okay. Because I see it's recording here.
Okay, good. It's okay.
Yeah, no problem. All right, so yeah, first question, first simple and basic question is what's a function in general? Let me know, guys, if you don't see the board. I mean, I'm using an iPad, but if you don't see the board, just let me know. All right, so what's a function? Well, a function is actually a correspondence or a mapping between two sets. Okay, so here's the definition of a function. This is like a very general definition of a function. So a function is, so it's a correspondence okay, or if you prefer it's a mapping. Okay, between two sets. Okay, so from a first set, the first set is actually called the set of inputs. Okay, so from a first set. Okay, so this first set is called actually the set of inputs. Okay, to a second set, right? And the second set is actually called the set of outputs. Okay, from a first set to a second set called the set of outputs. And actually, this correspondence or mapping obeys one rule. So the set of outputs. And so the rule is the following. So such that okay, well, each input in the first set corresponds to exactly one output in the second set. Okay, so so I'm going to give you a couple of examples, guys. Okay, don't worry. So each says that each input in the first set corresponds to exactly So the key word here is exactly one output in the second set. Okay, so one output in the second set. All right, so here are some examples. Okay, so this is a very general definition of a function. So what we are saying is there is a correspondence between two sets a first set called the first set of inputs, and the second set called the set of outputs, right? And the rule is the following. So each input in the first corresponds to exactly one output in the second. So, so here's an example. Examples. Okay. So, so let's say we have two sets, right? So we said the function is correspondence between two sets. So here's my first set. This is my first set, right? Oops. So this is the first set. Again, this is the set. So this first set is called the set of inputs, right? And there is a second set. So it's really important, guys, to distinguish between the two sets, right? Between the set of inputs and the set of outputs, right? This is the second set here. This is the second set, and that's the set of outputs. Now, so each set has like elements. Let's say here I have, let's say in the first set, let's say I have 4 points. Okay, here's my first point, my second point, my third, and my fourth point. Okay, so in the first set I have, let's say four different points or 4 different values. All right, and the second set I have, let's say three different points or 3 different values. All right, and now, so what I'm saying is, well, so we have a correspondence between the two sets. So what does it mean to have a correspondence between the two sets? Well, it means that you associate to each point, like from the first set, a point in the second set. So for example, let's say this point here, this one here, I'm going to associate, or so I'm going to associate to this point, let's say this one here. Okay, so in other words, this point here is the image of this one here. Okay, I'm going to do the same for the second point. So this one here, let's say this one here goes here. Okay, and then my third point, this one here, say goes to the third point here in the second set, and my fourth point goes to, let's say, to the third point here in the second set. Okay, so I have this correspondence between the two sets, right? Now the question is this correspondence a function, right? So the question is this a function?
No.
It's actually a yes. Why is that? So the rule, guys, we said each input, right, in the first set corresponds to exactly exactly one output in the second, right? So like this is my, let's say this is my input, right? So this input here corresponds to exactly one output here in the second, right? The same for the next point. So the next point, I have, this is my input, and so this input corresponds to exactly one output. Same here, this is, so this point here corresponds to exactly this point, all right? And the same for this one here, this input corresponds to exactly one output in the second set. So this is actually a function. Okay, this is okay. So here, I think you said no, because you would say, well, my second point, like this second point here, and then let's see, where is it? My fourth point here, right?
Yes.
That they have the same image, but that's not a problem, because the idea is each input corresponds exactly to one. So this one here corresponds exactly to this one, and this one here corresponds to exactly to this one. So that's not a problem. Even if they have the same image, that's not a problem. It's still a function. Okay. Now, Now let me give you an example where it's not a function. Okay, so yes, this is a function because as I said, each input corresponds to exactly one output. So even if so 2 points, let's say, having the same image is not a problem. Having the same image is not, it's not a problem. Okay, it's still a function. All right, so now let me give you an example where it's not a function. Okay, so second example. Again, guys, please, if you are confused, if you have a question, please let me know. All right. Okay, so second example, I'm gonna have the same set. So here's my first set of inputs, and then we have the second set here, the set of outputs. Second set, and again we have, let's say here is 4 points, or let's say just 3. All right, and here 2 points, or let's take 3 here. Okay, so what I'm gonna do, I'm gonna associate. So let's say to this point here, this one here goes, let's say here. All right, the second point, let's say it goes, let's say here and here. All right. And my third point, let's use the green, I guess. My third point, let's say, just goes to the third point in the second set. Okay, guys. Now the question is it a function? Is this a function?
Yes.
No.
And no. I am right.
No?
Absolutely. So yeah, it's not a function. It's not because. What will be the reason?
Because
the
one of
second
the
one
inputs is 2 outputs.
Because
Yes.
the second one has 2 outputs.
Yes, exactly. Because
Okay.
this point, this one here, this point here
You have just
has
one.
Yeah.
One input, one output, right?
Yes. So the idea is each input has exactly one output. So there's a problem with this point because it has 2 outputs. It goes here and here, right? So that's a problem. And so yeah. So in this case, this is not a function. So this is a problem. So this point has 2 images, or has 2 outputs, images. Okay, and so that will be a problem. So that's a problem. So it's not a function. Okay, so it's not a function. So this is not a function. Okay. So yeah, so that's the idea. Whenever you have an input which has like more than one image, it has like 2 images or 3, all right? So it's more than one image, right? If it has more than one image, then that's not a function, right? So let me finish with a third example, guys, and then I'm gonna give you an exercise. I'm gonna give you like a couple of correspondence, and then you have to say whether it's a function or not, okay? So let me give you a third example, a different, like a slightly different example with, again, 3 points here. Again, this is the first set. So you see, guys, here it's really important to distinguish between the first and the second set, right? It's between the set of inputs and the set of outputs, right? So here, let's see, here's my second set. And with 3 points. All right, guys, so let's see. Okay, let me use green. Okay, so this one here, let's say it goes here. The second point goes here, and the third point goes here to the second. Okay, so that's my correspondence. So my question for you guys, of course, is this correspondence a function?
Yes.
Yes.
Yes, it's a function.
Yes.
Absolutely. Even if, this point here, this one here, right? It doesn't have like a pre-image, right? So this point here is not associated to any point in the first set, but that's not a problem. We don't really care about the points in the second set with no pre-image. So this is not a problem. Okay. So the only thing you care about, guys, is that each input has exactly one image. So this one here has exactly one image, and the third point here has exactly one image. Okay, so yeah, as you said, guys, so this is a function. Right? Any questions, guys? All right, so here's an exercise. So I'm going to give you a couple of correspondence, right? And you have to think about them. I mean, you need to say whether they are functions or not, right? So exercise. So are the following correspondence. So are they functions? Okay, and you have to, of course, you have to justify your answer, okay? In some sense. All right, so so here's my first correspondence, my second correspondence. Here's my first set. So that's my set of inputs. Here's the same here. First set. And here's my second set. Set of outputs, right? So second set right here. All right, guys. So okay, so let's say you have here, let's say we have 3 points. Here we have 2 points. 2 here, and there are 3 here. Right, and let's say we have the following correspondence. So this one goes here, this one here goes here, and here, right? And the third one goes here, right? Now number 2, let's say number 1 here goes here, and number 2 goes to the first point here in the second set. Okay, guys. All right. So let's say you have like I guess it's not really hard exercise. So let's say you have 2-3 minutes, guys, to think about this exercise. So you have just to say whether it's function.
Number 2 is a function. Number 1 is not a function.
Exactly. Number 1 is not a function, and the second one is a function.
As a function. That's
Yes.
right. That's right. But probably some people, they're gonna need a couple of minutes. So I'm gonna just give you 1-2 minutes to think about it. Okay.
Professor, can I ask something?
Yeah, please.
So you said one input can have 2 outputs, right?
No, I said each input has exactly 1 output.
But the first example.
So I agree. The first one is not a function. The second one is.
Yes, absolutely. So, right. So, okay. So, yeah, the first is not the set. Yeah, it has 2 images. Yes, absolutely. So, all right. So, so as you said, guys, so the first one, this is, so this is not a function. And the problem would be, so the problem is with this point, right? Because this point has like 2, has 2 images, right? It corresponds to this one and to this one because we have 2 arrows, right? So, which means this point has 2 images, right? And so if the input has 2 outputs or 2 images, then the correspondence is not a function, right? For number 2, as you said, guys, so number 2 is a function. So this is a function. This is a function because So this is a function because, yeah, so each input has exactly or corresponds to exactly one output, right? This one here corresponds to exactly to this output, and this point corresponds exactly to this one here. Okay, and again, guys, this point here is alone, but it doesn't matter. It's in the second set, so we don't really care. All right, so that's like the very general definition of function, right? So again, what you need to keep in mind, guys, is that each input has exactly one output. All right, so now next we're gonna try to describe functions, and there are different ways actually to describe. I mean, there are many ways to describe functions. Okay, but actually we're gonna focus on two important ways to describe functions. All right, so next, so we're gonna describe functions. As I said, there are two important. So the question is, so how do we describe functions? Okay, and so the answer is, well, there are many ways actually to describe functions, but there are two important ways. So let's say there are two important ways to describe functions. All right, so first way, we're gonna use algebraic equations. So describe functions. So, so the first way we're gonna discuss is using equations. So first, using algebraic equations. Okay. So I'm gonna start with an example. I'm gonna explain with an example what do I mean by algebraic equation, right? So an example. So in the algebraic equation, so let's say we have the following. Let's say we have x squared plus y squared equal to 1. All right. Well, first, let me say, so when we have equality here, right? This is this symbol here. Okay, so this is an equation because we have this symbol of equality, right? So this is equality. So we have an equation. So that's what I mean by equation, right? So whenever you have like an equality, that's an equation. Now, here we have these two letters, right? We have x and we have y, so they are variables. And so the x is assumed to be the input. So the variable x, so this is like a convention, right? So the variable x is supposed to be the input. The input. Okay, and the variable y is assumed to be the output. The variable y. So this is like our convention, right? So whenever you have x and y, your x always represents the input and the y represents the output. Okay, so the variable y is assumed to be the output. Okay, so this equation here, x squared plus y squared equals to 1. So it describes like sort of relation between the variable x and the variable y. Okay, so I mean x, it's a variable because it can take any value, right? X can be any real number. Okay, so we have this, the input X, we have this output Y, right? And we have this equation, which represent like sort of relation between the input and the output, right? So this is, so this equation, right? So this is like our correspondence between the input X, and the output Y. Okay. So again, this is like in our definition, we said we have like the correspondence between two sets, a set of inputs and the set of outputs, right? So whenever you have X, then X would be your input. Whenever you have Y, that will be your output, okay? And if you have an equation, so the equation describes like a relation between the input and the output, right? And that relation is your correspondence. Anyway, so now the question we're gonna try to answer is whether this equation here represents a function. Okay, so the question is this equation correspondence.
Yes.
Okay. X squared. Actually, the answer is no, but I'm going to explain, of course. Equal to 1. So is this correspondence or equation represent, or does this equation represent a function? Okay, so let's just remind you, what's the rule? The rule is each input X corresponds to exactly one output Y, right? So to answer this question, we're gonna have like 2 steps. First step is, so step 1, so the answer. So we're gonna have 2 steps. So to answer the question, so first, in the first step, guys, you need to well, you have to try to solve for Y. So in the step 1, okay, you need to try to solve for Y. Okay, so what do I mean by solve for Y? I mean, you need to express Y in terms of X. Okay, so express Y.
Y square equal to 1 plus X.
Excuse me, Rabiul?
Oh, yeah, no. Y square is equal to 1 minus X square.
Yeah. I'm gonna do that in a minute. Yes. So express Y in terms of X. Okay. And then in the step 2, we're gonna check our rule, and our rule was, so the check the rule. So what was our rule? Well, each input has exactly, one output, right? Each input X corresponds to exactly one output. Okay. All right. So let's try to follow these steps. And so the equation is, so in the step 1, so here's our correspondence or equation, relation between X and Y. All right, this is the relation between X and Y. And as I said, in the first step, I need to solve for Y. Okay, solve for Y. Okay, so what I'm gonna do, I'm gonna move the x squared, let's say, to the right side, right? So I'm gonna subtract from x squared from both sides, right? So then, that will be y squared equal to 1 minus x squared, right? And then, well, we are not done yet because this is not exactly y, this is y squared, right? So I need to get rid of the square. So how do we get rid of the square, guys?
Square root.
Square root, absolutely. So so here's my square root. Oops. So here's my square root, both sides. Okay, but we need to be actually careful because when you have so here the power of y is actually even, right? We have y squared, so the power of y is even, and whenever you have even power, then when you take the square root, you're gonna need the plus or minus. So here we're gonna need a plus or minus in front of the square root. Okay, so we're gonna need because of the even power, because the power of y is even, okay, we need plus or minus. Okay, so so in this case, of course, here's your square root and the square, they cancel out, and so your y would be, so then y would be plus or minus square root of 1 minus x squared. Okay. So as I said, guys, here the power of y is even. So because if, let's say, you have y cubed equal to, I don't know, wherever, let's say 1 plus x, for example, right? And you want to get rid of the cube, right? So we're gonna apply, to get rid of the cube, we're gonna apply the third root, right? So third root. So here's my third root. Here's my third root. Okay. So this third root here cancel out with the cube, right? Now my question for you is, do we need a plus or minus here in front of this third root of 1 plus x? Well, the answer is no, because the power of y is odd, right? So then y here, y would be equal to just the third root of 1 plus x. Okay, so as you can see, there's no plus or minus. Okay, no plus or minus, because the power here is odd. Okay, so whenever you have even power, you're going to need the plus or minus. And if the power is odd, there's no need for plus or minus. Anyway, so it's just to remind you this rule here. All right. Anyway, we're going to have similar examples later. So, okay, I got my y. So my y, yes, there was a question? I guess no. All right, so yeah, so I got my y, right? So y is equal to plus or minus square root of 1 minus x. So I am done with the first step, right? So first step, we need to solve for y, okay? Now, the second step, we need to check our rule, right? We need to check if this is a function or not. So the x is supposed to be input. The y, that's my output, right? And again, the idea is, in order to be a function, each input corresponds to exactly one output. So for example here, if my x, let's say, is 0, I'm just taking a random example, right? So if my x is 0, what will be y? So here's the step number 2. So as I said, in the step number 2, we need to check if each input, okay, and each here is really important, each input x has exactly one output y. So now, because I solve for y, I have my y expressed in terms of x, right? So what I can do is, like, I can I can replace X by some values and see if I get exactly one output. But you can see here, guys, well, if X, for example, if X is 0, so if my input X, if the input X is 0, so what will be the output? The output Y would be equal to, so I just replace X, here by 0, right? So Y would be plus or minus square root of 1 minus 0 squared, right? So then Y would be plus or minus 1. Okay, so what I'm saying here is that if my input X is 0, then I'm going to have two outputs, plus or minus 1. So do you think this is a function or not?
No.
No, because if my input X is 0, I got two outputs, plus or minus 1, right? So in other words, what I'm saying, guys, is that, like, remember I had these two sets, right? This is like sets here, first set, and here's my second set, right? And what I'm saying is that if my X is 0, so here's X is equal to 0, right? So this is like a point here, right? And here I have, let's say, here is Y equals to 1 and Y equals to -1. Okay, and what I'm saying is that if my input X is 0, I got two outputs, right? Plus or minus 1. Right, so in this case, this equation here, or this correspondence, or this relation actually doesn't represent a function. It's not a function. So
Professor,
what? Yes.
sorry,
Yes,
I
please.
have a quick question.
Yes.
I think I said yes for the wrong reason, but so X and Y don't have to equal the same thing?
No, they don't have to equal the same thing. I mean, X and Y, X and Y, there are two different variables.
Okay, because at first I was coming into it thinking it should equal the same thing, but it
No,
should.
no, no, no.
Okay.
No. Like X is supposed to be like X and Y.
Okay.
They are just two different, completely different variables.
Okay, so if it only had one Y equals, let's say 1, it would have been a function because there would have been one input and one output.
Yes.
Okay.
Yeah, that's a good point. So you see, there's a problem. Well, if you say well, my input X is positive 1. Let's say positive 1. Okay, so then what will be my output Y? Well, output Y would be well, plus or minus square root of 1 minus 1 squared, which is 1 squared, of course, is just positive 1. So that would be 1 minus 1. So Y would be plus or minus square root of 0. Square root of 0 is 0. 0 times 0 is 0. So that's plus or minus 0, and plus or minus 0 is just 0, right? So here, if you take X equal to positive 1, right, you get exactly one output. Okay, but if X is 0, you get two outputs. Okay, so it's like saying if my X here is positive 1, well, I'm gonna get one output, which is Y equal to 0 here. I'm gonna get one output. Okay, but that doesn't matter, because there's a problem with X when X is 0, right? When X is 0, we have two outputs, and that's a problem. So then this correspondence is not a function, right? So this is a problem here. So all I'm saying, guys, is well, the thing is, because of this plus or minus, so the idea is because of the plus or minus here, so like in general, you're gonna have two possible outputs, right? If you take some random value of X, well, I said x is 0, but let's say you take x is equal to half, or x is 1/3, or whatever, okay, and you do the square root, and then you're going to have this plus or minus, right? And because of this plus or minus, well, unless it's a plus or minus 0, it's going to be two different values, right? Because of the plus or minus. So whenever you end up with a plus or minus, it means that your equation is not a function, right? So this is, so in general, the plus or minus means that y, so in general, plus or minus means that this relation or correspondence is not a function. Means it's not a function, right? Because again, just take a random value of x. Well, here x has to be less than 1 because, you know, under the square root we're supposed to have only positive or 0. But if you take some random x less than 1, then you're going to end up with two possible outputs, right? So so the answer, anyway, so the answer to this question is, so find an answer. So find an answer so the equation or the relation, so the equation x squared plus y squared equal to 1 do not represent a function. Okay. Again, here, what we are saying here is that the x is supposed to be the input, right? The y, that's our input. And so this is not, so this equation is not a function. Is there any question, guys? Do you see why this is not a function? So again, there are two main steps. Whenever you have an equation, right, between x and y, and you want to determine whether the equation is a function or not, there are two steps. First step, you try to solve for y, okay? Once you solve for y, then you check if for each input x, you're going to have exactly one output. And so here, so I solve for y, and then I said, well, if my x is 0, then I'm going to end up with two outputs, plus or minus 1. Okay, but you can also say, well, because of this plus or minus, well, then this equation is not a function because of the plus or minus, right? It means that you can always, in general, we're going to have two outputs. All right. Is there any question about this example, this particular example? I'm going to do another one, but no questions about this one? All right. So then here's another example. So example number 2. Again, we think of x as the input, and we think of y as the output. Okay. And the question is or does let's see, well, minus x, let's say, plus y cubed minus 2, well, let's say equal to x squared. Okay, so does this equation here represent a function? Okay, so again, guys, this equation represents your correspondence between your input x and your output y. So to answer such a question, we have two steps. So in the first step, we have to solve for y, try to solve for y. And actually, it's not always possible to solve for y. I'm going to give you later an exercise where it's not, sometimes it's tricky to solve for y. But anyway, so in this example, so first step, as I said, we solve for y. Y. Okay.
It's a function.
So, yeah, it's gonna, yeah, that's true. It's gonna be a function. Yes. So let me show you the steps. All right. And then I will give you an exercise. So here's my x minus x, sorry, plus y cubed minus 2 equal to x squared. As I said, we need to solve for y. So here's plus x, both sides. Here's plus 2, both sides. All right. So minus x plus x minus 2 plus 2 cancel out. So this is just y cubed now on the left side. On the right side, we have x squared plus x plus 2. All right. Now, it's still not exactly, this is not exactly y. Get rid of the cube, and it's a cube. So to get rid of the cube, we apply the third root, right? So if you have y to the power 4, y fourth, you apply the fourth root, right? Y to the power 5, you apply the fifth root, etc. Right? So this is a cube, so I'm going to apply the third root, both sides. So here's my third root. Okay. So this third root here and this cube, they cancel out, some sense. And now, as I said, because it's the power is odd, so this is a cube, right? So 3 is odd, power 3 is odd. So then there's no need for plus or minus. So there's no plus or minus. Okay. So this is different from the when we had the y squared, right? Y squared, we needed the.
Yeah, I got lost, Professor. After
Yeah,
the
please.
second, yes, after the second transaction down here. The plus
second,
x, yes.
this
plus
one here.
X,
Oh, sorry. Plus x, yes.
plus 2.
Yeah, it's because you see there's a minus
Trying to
x
cancel
here.
it out. Okay. Mhm.
Yeah, they cancel out because I need to solve for y, right?
Yes.
So I need to solve for y, so I need to get rid of everything else. So I need to get rid of this minus x, and I need to get rid of this minus 2. All right.
Okay.
So the way to do it is, you have to do like the opposite operation, right? So if you have like minus x, so what you do is the opposite operation to minus or to subtraction would be plus, right? And here's the same, minus plus, right? So they would cancel out this minus x plus x and this minus 2 plus 2, right? And then that's why I got my y cube. And don't forget, you need to do the same operations on the right side. So if you had plus x plus 2 on the left, you have to do the same because it's an equality, right? You have to do exactly the same thing on the right side. So that's why I have this plus x here and the plus 2, because I had this plus x plus 2 on the left, right?
Okay.
Okay. So then on the right side now I have like x squared plus x plus 2. Okay. And on the left side I have well, minus x cancel out, minus 2. So now I end up with the y cube. Okay. Now, once you have this y cube, as I said, because we need to solve for y, so it's y cube is not exactly y. So you need to get rid of the cube, the power 3, right? And the way to do it is to apply, if you have power 3, you apply the third root. Okay, that's what I call here the third root. I had y cube, so I apply the third root. So this is y. Okay, this is what I call the third root. Right, it's like a square root, but square root would be when you have like.
Where is that coming from?
What? The third root.
Cube.
No, because the idea is I need to get exactly y. So, and let me just probably erase this here, so I can show you exactly what I'm doing, what I did. So Now, you agree? So on the left, I had y cubed, right?
Mhm,
This y cube here. And I got this x squared plus x plus 2 on the right.
mhm.
Okay, now what I'm saying is I have to solve for y, and y cube is not exactly y. So I need to find a way to, get rid of this cube, this power thing.
I see. Mhm,
Okay, and the way to do it, if you have power 3, to get rid of the power 3, you apply the third root
mm,
to both sides.
mhm.
So I have to apply to get rid of this cube. I'm gonna apply the third root here on the left, and because it's an equation, you have to do exactly the same on the other side. So on the other side, I have to apply this third root too.
Oh, let's see.
Okay.
Mhm,
Now, this third root and this cube, they cancel out, and that's why I'm gonna end up with exactly y now. So now I'm gonna have exactly y on the left side,
mhm.
and on the right side, well, it's again, it's this third root. There's no simplification on the right side, okay? Because there's no cube, or so it's third root of x squared plus x plus 2.
Plus 2. Okay.
Okay, does this make sense to you now?
Yes, it does. Mhm,
Okay, perfect. Now, there's one thing, just be careful. As I said, you have to be careful with the power. Like here, this is a cube, this is an odd power. So when you apply this third root thing, you don't need the plus or minus in front of you don't need the plus or minus here. Okay, because remember in the example of the square, you see here, in the example of the square, we had this plus or minus.
mhm.
Okay, when you say, I mean, we had the square, so apply. This is a square root. So square root, like it's a second root, right? This is like a square root, right? So we needed the plus or minus because the power was even.
Uh-huh.
Okay, but now in this example,
The 3 is odd.
It's odd, so there's no plus or minus. Okay,
Mhm,
that's the main difference with the previous example.
mhm.
Now, so now I got my y. So this is like the first step. So I'm done with the first step. All right. So that's my first step. Now I can move to the next step. Now in the next step, step 2, remember, we have to check if this equation represent a function, right? X is supposed to be my input and y is supposed to be my output. So we need to check if for each input we have exactly one output. So let me just write it down here for you. So we have to check in this second step, we have to check each input. So you have to check if each input X has exactly one output Y. Okay. Well, you can take a couple of values. I mean, for example, if X is 0, for example, if let's say X is 0, what would be Y? Well, Y is like third root. This is a 0 square plus this is 0 here plus 2, right? So Y would be third root of, 0 plus 0 plus 2, that's 2. So this is third root of 2. Okay. So here, what I'm saying, if my input X is 0, I have exactly one output, which is this third root of 2. Okay. You can take another value of X if you want. So for example, if X is 1, then Y would be like third root of like 1 square plus 1 plus 2. But anyway, you're gonna still end up with exactly one output, right? This is like third root of what? Let's see. So 1 plus 1 plus 2, that's 4. That's third root of 4, right? So, but it's still just exact. It's one value, right? So we have exactly one output here. So anyway, if you take any value of X, you're gonna always end up with exactly one output Y. Okay. And so, so the conclusion is that this equation represents a function, right? So you see the main difference in the previous example is that there was no plus or minus here. And because of that, each input X corresponds to exactly one output Y. Okay, so anyway, so here conclusion is that so each input, so this is exactly one, one output, right? Exactly one output here. Exactly one output. So each input X corresponds to exactly one output, and so corresponds exactly to one output, and so the equation represents to one output Y, right? And so so the equation minus X, what was it? Minus X plus Y cubed minus 2 equal to X squared is a function. So this is a function. Any question, guys, about this example?
Are we only finding the y-intercept? Or we're
No,
doing both?
No. Here we are not doing the y-intercept. The y-intercept is going to be another story, right? So here I'm in the first step, I'm solving for y, the variable y. Okay. First step, solving for y. Second step, I'm going to just check if each input X has exactly one output. Does this answer your question? So here we are not doing
Yeah.
y-intercept. We're gonna see y-intercept later. That's another story. Y-intercept is another story. Okay, that's a different story. Yes, please.
So we substitute the X for 0 or 1.
Yeah, well, here I just took a random values of X, but in general, what you have to do, guys, is just make sure that there is no plus or minus here in your answer. I mean, if there is no plus or minus, then you're gonna have an equation, right? I just took just random values here of X to see that I have exactly one output. Okay, so in the test or in the homework, all you have to do is just take one or two values of X, just check if you have exactly one output, and then and then you can say whether the equation is a function or not.
Okay, thank you.
Okay, make sense? Okay. All right, so here's an exercise, guys. So anyway, so you're gonna practice these steps. All right, so please try to follow these steps. I think I mean, the best way, so first question in the test, I can tell you, on Monday, first question of the test would be determine whether the equation is a function or not. So you're gonna have a similar problem in the first problem in the test is gonna be similar to this exercise, okay? So here's an exercise for you guys. Exercise. Because this is like a first step in this section. Anyway, so here's an exercise. So you have to determine whether y. So determine whether the equation or the equations represent functions. Okay. Let's see. So first, number one. So let's say you have minus. So again, here we always assume that X is the input, right? And my Y is the output. Again, X and Y, they're completely different variables, okay? Well, of course, the equation gives you like a relation between x and y. But in general, I mean, like x, it's your input, so x can take any, can take any value, right? And so they don't have to be the same. Okay, they're actually in general they're not the same. So first equation, guys, minus x fourth plus y, let's say minus 2 equal to x. Number 2, minus x cubed plus y fourth equal to 1. Three. So y to the power 7 minus x equal to 2. And the last one, this is kind of a little bit tricky. Number 4. So let's say minus x cubed plus y squared. Let's say minus y or minus 2y equal to positive 1. All right. Yes. Yeah, I'm gonna give you time. Yeah. Yeah, sure. Yeah, I'm gonna give you time to think about this exercise. So this is an important exercise, guys. As I said, because probably the first question in the test would be a similar problem. All right. So your x is your input, your y is your output, and you have to determine whether these equations are functions. I see there's some questions in the chat. I'm sorry if I missed your question in the chat. I have to talk and write at the same time, so sometimes it's not obvious. Anyway, all right, guys. Let's say you have 5. Yeah, let's say 5-10 minutes to think about this exercise. And of course, if you have any question, I'm here to answer your question. So as I said, guys, so the session is recorded. I'm gonna upload all the videos on YouTube, and I will send you the link. And for the homework, as I said, we are supposed to have like a daily homework. So tomorrow I will probably post the first homework, and it will be due like in like 2 days or something. 2 days. That will be enough. 2 days to do the homework. I mean, it's an intensive course. I know it's like we have lecture every day, but well, yeah, well, yeah, but I think the best thing to do, guys, just to follow the steps, right? If you know the steps, then okay, you haven't done math in years. All right, well, Lorden is material. Yeah, okay. So first step, you solve for y, you try to solve for y. Second step, you check the rule, if the rule is satisfied or not. And I know, I mean, probably some of you guys have trouble, have trouble solving the equations, right? Solving for y. Um, yeah, so the idea is, is to move everything else to the right side and keep, let's say, y on the left side, right? Yeah, yeah, that's why you need actually some practice. I guess with yeah, I guess you probably can practice with the homework. But yeah, I know some of you have trouble with the solving. So we're supposed to have a lecture until 10 a.m. As I said, we'll have a break at around 8 p.m. Break of 10 minutes. But as I said, guys, we have a lot of material to cover. So we're gonna need every minute. Okay, so I know, I mean, like 4 hours is a lot, but well, with the break of 10 minutes, we should be okay. And as I said, I'm gonna upload the recording on YouTube. So even if you miss something, then you can always check the videos. Is there any question in the chat? Destiny? Okay, all right, that's good. Where's the text one this time? This is a section 1.2 in the textbook. I'm not sure about the page, actually. I need to check, but it's supposed to be section 1.2. I need to find the textbook. Yeah, so it's section 1.2. Oops. Let me know, guys. So if you are done, I'm gonna give you probably 2 more minutes, and then I will go over the exercise. All right. As I said, the number 4 kind of tricky. Where I can't find the textbook. Well, I guess in the bookstore. Or yeah, Amazon. Yeah, Amazon is actually cheaper on Amazon. Yeah, but as I said, Elizabeth, actually, it's not. The textbook is really optional here. It's optional, and I can try. Actually, I have a PDF. I mean,
What
PDF
about
version of.
What about
Sorry?
on Cengage, Professor?
Cengage. What do you mean? Like, if you want to find, you can.
Yeah, if you could use the Cengage setup.
Yes, I never actually. It's weird, but I never used the Cengage. But I think it's possible. I'm not sure actually. I have to check. But I mean, if you guys you cannot find the textbook, I have a PDF. Well, I'm not supposed to. I'm not. But anyway, I mean, I have a PDF file version of the textbook, so I can send you like by email, probably by Gmail, because the size of the file is I guess is big. But I mean, I can try to send you by email if you can find the textbook. But as I said, it's optional. Of course, there are a lot of problems in the textbook you can practice, but I'm gonna try to do my best to cover everything you need. Give you homeworks on Blackboard. So like I would say, like in practice, I mean, in theory, yes, you probably need the textbook, but in practice, I don't think so. All right. Okay, time is over, guys. I guess I'm gonna go over the exercise unless someone needs more time. Okay, no one. All right. Okay, for number one, any guess? Is it is the equation represent? Does the equation represent a function? Number one. Yes.
Yes.
Yes,
Yes.
the first
Okay.
one, yes.
Yes. Very good. So, okay. So first step. So here's my equation. So it's minus x power 4 plus y minus 2 equal to this to x. As I said, we need to solve for y, which means, so I'm gonna keep this y here, right, on the left side, and I'm gonna get rid of anything else on this left side, right? So this is minus x to the power 4. So the opposite would be plus x to the power 4. And because I add plus x to the power 4 on the left, I need to do exactly the same on the right side. So here's my plus x to the power 4. This is a minus 2. So I'm going to need a plus 2 here to get rid of this minus 2. And then I have to add plus 2 on the right side. So this minus x fourth cancel out. This minus 2 plus 2, so 2 cancel out. So now I got so I have now a y on the left side. So this y here, as you can see, here's my y. All right. And on the right side, I got, so this is like x plus x fourth plus 2. X plus x fourth plus 2, right? So now I got exactly y, right? So there's no need for square root or, you know, there's no need for anything, right? So I have exactly y, and that's a good news. So now I can move to my second step. So step number 2. So I have to check if each x has exactly one output y. Okay, so you can just probably take 1 or 2 values of x to check if you have exactly one output y. So if x, for example, let's say if x is 0, then y would be, you know, 0 plus 2, that would be positive 2. But anyway, the point is we have exactly one output, which is 2. Now I can take another value if you want, just in case. So this is 1 plus 1/4 plus 2, you know, that would be 4, and we get exactly one output. So anyway, so
I have a question.
yes, please.
So what would X be in this case? And for question number 1, what would X be?
Question number 1. You mean the
Like
first
the one
step?
yeah, for
fir-
the one we're doing right now, what would X be?
Whatever value you give it.
Yeah, you take any value. I'm taking just random values here. I'm just
Like,
taking random values.
Yeah.
So I'm taking just random values to see if I get exactly one output. Instead of 0 and 1, I can take, I don't know, I can take, let's say, positive 5, okay? Or, you know, we can take 7 if you want. Any random, just a couple of random values, just to see if I get exactly one output, right? So that's what I'm doing.
Okay.
It's just some
Thank you.
random values of X to see if I end up with exactly one answer. Right. Of course, here if X is 5, this would be different. But I mean, I took 0 and 1 because it's very simple. You know, it's very simple to evaluate. But you can take any, as I said, just any random value. Sorry. So here, just that's 0 and 1. Is there any other question? Oh, well, I'm not done yet. But so the point is, so for these random values of X, I got just exactly one answer, and so I can conclude that. So conclusion. So my equation, what was it? Yeah, minus x fourth plus y minus 2 equal to X represent the function. Is a function represent. Is there any other question, guys? All right. So for number 2. Any guess from number 2? So number 2 was, I think, minus x cubed plus
Not a
y
function.
fourth.
It's not a
Excuse me? Yeah, it's
Not
not. Yeah, it's not, because so first step, yeah, lower than absolute, it's not a function. So step 1, as usual, I'm gonna solve for y. So I'm gonna this is minus, as you can see, this is minus x cubed. So I'm gonna get rid of this minus x cubed. So I'm gonna have plus x cubed here. We have to do the same, exactly the same thing on the right side. Okay, so then this thing here cancel out, and I got now y fourth. Yes, Lord, no, absolutely 1 plus x cubed. All right. Now this is not exactly y, but I can get rid of this power 4 by applying the 4th root. All right. So I'm gonna just write it again here. So I have this y to the power 4, 1 plus x cubed. All right, and so I need to get rid of this power 4. So again, the trick is just to apply the nth root, right? So this is power 4, so it's going to be 4th root. Okay, so here's my 4th root, both sides. So now I get rid of this power 4. So now I have exactly the exact expression of y in terms of x. So it's y is the 4th root of 1 plus x cubed. Okay, and now in my next step, I can check if for each input x, there's exactly one output. But here, guys, as you can see, there's something missing, right? Because plus or minus, because there's the plus or minus here, there's a plus or minus here, and that's because we have an even power. So 4 is even, so we need plus or minus. Yes, absolutely. Power is even. Power of y is even. So we need this plus or minus. Okay, and so now I can move to the next step. So step number 2. So I'm gonna check the rule. So again, my y is supposed to be plus or minus this 4th root of 1 plus x cubed. Again, you can just take very simple values of x. That will be very simple to evaluate. So I'm gonna take again x is 0 because again it's very simple, to compute, right? But I mean, you can take, well, instead of x is equal to 0, let's say my x is 99. Okay. So then y would be plus or minus this 4th root of 1 plus 99 cubed. That would be a problem too. Sorry. Probably not 99. I'm gonna take a 100. That'll be easier. 100. Or not 100. It's gonna be a very large number. just going to take 10. Okay. Anyway, so it's fourth root of, so 1 plus 10 cubed. 10 cubed, that will be 1000, right? So then y will be plus or minus fourth root of 1 plus 1000. So that's plus or minus fourth root of 1001. Anyway, the point is, we have two possible outputs. Because of the plus or minus, two possible outputs. And so the conclusion is, as you said, guys, this is not, yeah, hence not a function, absolutely. So, so then this is not. It's not a function. Okay, so let's move to the next next equation. Unless you have questions, guys, please don't be shy. Feel free to ask questions. So number 3, we have, I think, if I'm not mistaken, so it's y to the power 7, right? Minus x equal to 2. All right, any guess?
Yes, it is.
Yes, it is a function. Yes.
It is a, yeah.
So step 1. Yes, one value, absolutely, Lorden. So that's 1 power. So y power 7 minus x equal to 2. Solve as usual for y. So here's plus x, right? Do the same on the right side. So then this is minus x plus x cancel out. So this is y to the power 7, which is 2 plus x. And then we'll get rid of the power 7. We're going to apply the 7th root. And so let me just write it down again here. 2 plus x. So to get rid of the 7th root, we're going to apply, the power 7, we're going to apply the 7th root. Yes. So 7th root. So here's my 7th root here. And we have to do exactly the same thing on the right side because, again, it's an equation, right? So whatever you do on the left, you do exactly the same on the right, or whatever you do on the right, you do exactly the same on the left. Anyway, so this is, so then this 7th root with the power 7 cancel out. And because it's, 7 is even, even is odd. So there's no plus or minus, okay? And so it's just y 7th root of 2 plus x. So I got my y. Now in the second step, just well, here, you know, guys, you can see what did you say, Lorden? Let's see. Yes, absolutely. So here, so step number 2, let's check our rule. Which is, so the rule again, guys, remind you the rule, each input x has exactly one output y. So this is y equal to the 7th root of 2 plus x. So I'm gonna just again take your random value of x just to make sure that I have exactly one output. So let's say x is 100. All right, then y is 7th root of 2 plus 100. So that's 7th root of 102. But anyway, so the point is we have exactly one output. Exactly one output. And so then, but anyway, just make sure that you have exactly one output. And so conclusion is that conclusion. So this is a function. So let's finish with the last problem, and then we're gonna take a break of probably 5-10 minutes. All right. Let's finish with number, excuse me?
The fourth one, I was.
Yeah, fourth one. Any guess for number 4? So number 4 is tricky, kind of tricky,
No.
right?
I'm
I-
gonna say yes.
Oh, no, I think it's no. I had to use a quadratic formula to find
Yes,
why.
it's a no for number, yes, it's yes.
No.
So, yeah, so let me explain why it's not a function. So number 4, it's tricky because it's different from the previous examples. Let's see how it works, right? So we said, I think minus x squared plus y squared minus 1 or minus y or minus 2y, I think, I'm not sure. Is it minus 2y or minus y? I mean, it's not 2, 1, okay, even better. Minus 2y equal to -1. Anyway, so so step 1, again, as I said, in step 1, you're supposed to try to solve for y, okay? It's not always possible. Actually, it's not always possible. Sorry, it's not always possible to solve for y, okay? Sometimes you cannot solve for y explicitly, okay? So let's try here in this case. Let's see what happens. So minus x squared plus y minus 2y equal to -1. All right. So, well, I'm gonna solve for y. So I'm gonna just keep the y's on the left side, right? I have, as you can see, I have y squared here and the 2y here, right? So I'm gonna keep the y's on the left and I'm gonna move everything else to the right side. So I'm gonna move the minus x squared to the right side. So what I'm gonna do, of course, is it's minus x squared. So I'm gonna add plus x squared, do the same on the other side. And okay, so then that will be y squared minus 2y equal to, -1, say, plus x squared. Okay. Well, here, there's a kind of problem because we have actually like 2 terms with y, right? We have this y squared and we have this minus 2y. Well, one thing you can do here, as you can see, y is a common factor here, right? This is y squared. This is y squared. This is 2y. So you can, for example, you can factor out y. Yes, absolutely, Lorden. So y would be a common factor here. You can factor out y if you want. So let's see, y. So we factor out y. So to get y squared, so you need to multiply y by y, right? To get y squared, there's a minus here. So here's my minus, and then it's minus 2y. So if you factor out the y, you're gonna have 2 here, right? So y times 2, that will be the minus 2y. And on the left side, it's minus 1 plus x squared. Okay, so here we just try to solve for y. But anyway, we can now try to move to the next step and see what happens. For example, so step number 2, I'm gonna check, I'm gonna see, step number 2, I'm gonna check if for each input x, I have exactly 1 output. So for example, so check the rule. So I'm gonna take some random value of x. So here, probably the easiest or the simplest value I can take for x would be 0 plus 1. So for example, if you take, let's say x is, let's say, +1. And you'll see why I'm gonna take +1, because if x is +1, then you can see on the right side, it's gonna be 0, right? So then, I have y times y minus 2 gonna be equal to -1 plus 1 squared. So y times y minus 2 is equal to 0. Okay, so as you can see here, I got 0 on the right side. So now, what will be my output y? if my x is positive 1. So here I have y times, this is a multiplication, right? Times y minus 2 equal to 0. So you think of, so here, this y here, you know, it's just some number times another, let's say, number here, which is y minus 2. So the product of these two numbers is 0. So the idea here, guys, is like whenever the product of two numbers is 0, it means that one of the numbers is 0, right? If you multiply two numbers and you get 0, it means that one of the number has to be 0. So here, because of this, the product here is 0. So then either this y here, either this y is 0 or this y minus 2 is 0. Okay. So this is because, again, guys, y is here is a number, right? Times y minus 2, which is another number. So you have a product of two numbers equal to 0. So if you have a product of two numbers equal to 0, then one of the numbers has to be 0. There's no other way. Okay, that's like
a function then.
Yes. So then y is 0, and or y could be equal to well, y minus 2 is 0. So of course, if you add plus 2 on both sides, okay, so then y would be positive 2. So yeah, positive 2, absolutely. So what I'm saying here, guys, is that if my x is positive 1, if my input x is positive 1, I got two possible outputs, y equal to 0 or y equal to positive 2. So let me write down what I just said. So if x is positive 1, then we have two possible outputs. Okay, either y is 0 or y is positive 2. Okay, so then this is not a function. Okay. If you can take another value for x. I mean, here I took x is equal to positive 1. You can say, well, instead of x equal to positive 1, I don't know, you take another value. For example, you take x equal to so just a remark here. Let's say you take if let's say x is 2, for example, or 3. Okay, then you're gonna have y times y minus 2 equal to negative. Right, it's negative 1 plus x squared. Okay, so it's negative 1 plus this phi squared, right, which is 9. So it's negative 1 plus 9, which is 8. Anyway, so what we are saying here, guys, is that y times y minus 2 is equal to 8, right? And now we have to solve for y. Well, so here, just be careful. I cannot use the same trick as I did here with a 0, because if you multiply two numbers and you have a 0, it means one of the numbers has to be 0. Okay, 5 times 0 is 0, but 5 times 1 or 2 or wherever, something different from 0, it's not equal to 0, right? Here, this is different. So here, what we are saying is y times y minus 2 is equal to 8. So you cannot say, well, either my y is 8 or y minus 2 is 8. That's not true. Okay, so here, just be careful. This doesn't mean that like y is 8 or y minus 2 is 8. That's not true. Okay, it only works for 0. When you have a product of two numbers equal to 0, then one of the numbers is 0. But if it's not equal to 0, then actually You cannot use this trick. So what I can do here, if you want to solve for y, well, you can just try to apply, here it's y times y minus 2 is equal to 8. So you can say, well, if you distribute, guys, I mean, y times y would be like y squared. Y times 2 would be minus 2y equal to 8. And then you can say, well, this is y squared minus 2y. You subtract 8, let's say, minus 8 here, minus 8 here. And then, so here's minus 8 equal to 0. So then this is like, a quadratic equation. Then you can use the quadratic formula to solve for y. Okay, so like in here, you can use quadratic formula to solve for y. Just to remind you the quadratic formula, if you have like, a x squared plus bx plus c equal to 0, then your x is minus b plus or minus, square root of b squared minus 4ac over 2a. Okay, so you can try to apply this quadratic formula to solve for y here. But anyway, you see, if you use the quadratic formula, because of this plus or minus in the solution of the quadratic formula, right? Because of this plus or minus, you're going to end up with two possible solutions. So you're going to have two possible outputs. And so again, it's not a function. All right, guys, is there any question about this? I know this one is kind of tricky, but is there any question about this one?
Is this how we're gonna solve everything and put into a Blackboard, Professor?
Yes.
So you
Yes.
just don't want just the answer, but you want the whole steps that we do, right?
Oh yeah, of course. Like in
Okay.
the homework, yeah, of course. In the homework, you have to justify your answers, right? I mean, no justification, no credits, for sure. All right, guys. Is there any other question? Nope. All right. So you know what? Probably we can take a break. So it's almost 8. So we've done like 2 hours. Let's take a break at 10 minutes. All right. And then we'll continue with the functions. So I will be back at 10 minutes. That would be what? 8:06 p.m. I guess, right?
Yeah.
Or 8:10. Oh, okay. 8:10. Okay. All right. So I'll be back at 8:10. Okay. So let's take a break. 10 minutes, guys. I'll be back at 8:10. Break 10 minutes. 10 minutes. So I because we cannot really do like 4 hours in a row, right? So that will be too much for you guys. So let's take 10 minutes break. So be back at 8:10. All right. Okay, see you in a couple of minutes, guys. I mean, I'm gonna also take a break, I guess.